Thank you so much, Christopher. I really keep on forgetting this. I'm really sorry for that. So like I said, today we're going to cover testing smart contract. Yesterday we did writing smart contract, a good or rather bit of it. So today we're basically going to finish up. Then we proceed with testing, deploying, and running those functions from the blockchain, right? So I think that is where we were. So right here in our index.ts file, or in other words, our entry file, I've just created a class and I've named it contract. And like I said, in this case, you can choose to name it anything you like. But usually the convention is naming it contract. So we're going to have in it a function new task that is basically going to create a new task. And I was saying that for you to create a new task, you ought to have signed in, or rather you need to sign this particular transaction for you to be able to achieve that, so that you don't have someone else viewing tasks that do not belong to them. Okay, so in this case, you're going to be required to sign in with your wallet address, and that will help us organize the tasks according to the wallet addresses. Now, in this case, we first of all are going to get the wallet address of whoever signed this particular transaction. And to do that, NEAR SDKAS avails to us this particular object called context. And from it, we can simply invoke, or rather get from it the sender. So that is basically going to give us the wallet address of whoever is going to sign this particular transaction. And after that, sorry, we need to establish that this is not the first time this person, we need to establish whether this is the first time this person is creating a new task or not. Now, to do that, we're going to have an if function right here that is going to help us achieve that. Now, just before I proceed, I think there's one thing I sort of forgot, and that is basically the storage bit of this. Now, for us to be able to persist this data, the tasks data on the blockchain, NEAR avails what we call persistent collections, sort of storage on the blockchain, so that whatever or anything you're going to store is going to persist in blockchain, so that after you're done, it doesn't go away. Okay. You realize that in blockchain, you don't have databases like MySQL, MongoDBs, and the like. So here we are presented by some sort of data structure that is going to persist our data on the blockchain. Now, we need to create, or rather to initialize that particular data structure for us to be able to use it to persist our data. Now, to do that, I'm simply going to create a file under our utils folder directory, and we're going to name it, what should we name this? Let's name this database, right? Or anything you like, guys. So in this case, I've just decided to name it database, and I'm going to export these as a constant. I'm going to name these my tasks. And this is how we initialize this particular storage, guys. So we're going to do new persistent map. We're going to use map. Now you realize that there are quite a number of persistent storage or persistent collections that NEAR has availed through these assembly script package or SDK. So we have persistent DQ, persistent map, persistent set, persistent unordered map, persistent vector. Now, persistent vector basically creates or stores your data in sort of array structure. It takes the array structure. So you can basically iterate through the data. Then persistent and ordered map is also, you can as well iterate through that, but they're given some sort of key. Now, persistent set and persistent map are all, they all basically work the same. In this case, they store your data based on the key you've provided. So your data is stored under a particular key. And that key will always be unique in the whole of that particular data collection. Okay, so like I said, in this case, you're going to use persistent map. You realize it has imported it from the NSDKS. And then we're going to store, okay, this is basically the structure of data we're going to store. It is going to take a key of type string. Then it's going to take the data that is going to be stored is going to be of type task manager, basically the class we created yesterday, okay? And after that, we'll need to sort of give it some prefix, okay? So that it is unique in the whole of the blockchain network and under the wallet that this particular smart contract is going to be deployed. So in this case, I'll simply give it, or rather prefix that with letter T and end it just like that. So this is we're going to use this as our database now on blockchain, okay? Let's proceed. So right here, we're going to test if this guy who is trying to create a new task is doing this for the first time or not. Now to do that, we're going to first check if their ID, or rather their wallet address, is within our database, in this case within our collection. So I'm simply going to pass in the signer right there. Now my task.contains, the method contains will return a Boolean variable. So if the key exists, it will be true, else that will be false. Now in the event that the key exists, we simply need to retrieve the task manager data type that we stored in there. So in this case, we're simply going to do const task manager is going to be equal to my tasks dot get sum. And by getting sum, we're going to pass the key, which is in this case, the signer wallet address. Now that is basically going to retrieve the task manager data structure we stored in there. Now, after getting this task manager object, after retrieving the task manager object, we're going to perform now these operations we defined yesterday right here. And in this case, we're going to use this method add task to store that particular new task. And you realize it's going to return some data that is going to take type task info. Now, let's do that. Created task, let's call it that way, created task. So this will basically be task manager dot add task, and whatever we are adding is taking the title that the user passed in while calling this particular function. So the created task is already stored inside our created task variable. Now, since that is created within this task manager object, we need to reflect that on blockchain, or rather we need to persist it on the blockchain network. In this case, it is still within the memory of the computer running this particular smart contract. Now, to store it in database, or rather to update that change on blockchain, we basically are going to do this, my tasks dot set, and we are going to set, in this case, our key is the signer or whoever is signed this called this particular function, and yet whatever you are storing right there is task manager. Okay, so that is how we do that. So in that case, we've stored that. Then we basically returning the created task, so that whoever is calling this particular function is able to get some sort of feedback of whatever they've done. Now, if this person was doing this for the first time, then that means that their wallet address is not on the blockchain persistent collection yet. So in that case, we need to create it from scratch, right? Now to achieve that, just after the if statement, we're going to do a const task manager, and we're going to initialize this to a new task manager. Okay. Then after that, we basically are going to now add this one. So this statement can get down here. So we're basically going to add the task they want to create. And after adding, we still need to have that persisted on the blockchain. And afterwards, we still need to return whatever they've created so that they also see it from their end. So that function should be able to create a new task. Now, let's proceed. After creating a new task, you simply want to show task. You may want to show task. And if you want to show tasks, now this is another function we are developing. If you want to show task, you basically want to pass the task ID. And in this case, we are expecting an I32. So that is basically an integer, an unsigned integer, or rather signed integer, sorry. So after getting that, we want to, let's see what this looks like from the task manager class. Okay. So we are returning task info. And in this case, we still want to establish if the collection contains this particular key. Okay. So if, let's also get the signer. Let's first of all get the signer. You'll realize we're going to have some redundant data within the class, but we can always refactor later. So let's get these. Then we get, we check if that already exists within our collection or our database. If that exists, then in that case, we simply want to get that particular task from our persistent collection. So in this case, my tasks dot get some. And in this case, we're passing in the wallet of whoever signed in. Then after that, we're going to return task manager dot get task. And in this case, they are getting task using the task ID that the user specified. Okay. If in, let's say, this user has no record within our persistent collection, in that case, this function will not find anything within the collection, right? So we need to return something still. So in this case, we're going to return null, just to indicate that nothing was found within our collection. Awesome. After that, we also need to, now you realize this is a view function because there's no change. We're not changing the state of the blockchain. Our first function was a call function or a change function because it was changing the state of blockchain at that particular point and at that particular point. We are setting something on blockchain, okay? But this one is retrieving. So in that case, it is basically going to be a view method. It's viewing the state of the blockchain, okay? Okay. So we're going to proceed with, now we may also want to show all tasks. So let's implement that particular function as well, right here. So we want to basically show all tasks. And to show all tasks, there's no need of passing in any argument. It's basically going to retrieve everything. So right here, we can, we still need the signer wallet address. And if that is already in our persistent collection, then we're simply going to retrieve that from our persistent collection and then return get all tasks, which is not accepting anything. So that in that case, it will return all the tasks. Otherwise, it should return an empty array, right? I think that makes sense. It should return an empty array. So in this case, you are returning an array of tasks. I hope that is clear up to that point, guys. Okay, if you have any question, you can simply put it in the chat. I'll see it. So from there, we're going to do what? Okay, you've added a task. You want to start a task. Okay. In this case, we're basically going to change its state to be active. So we can still return void for now. You need to specify the task ID of whatever task you're starting. Should be an I32. Then we still need this bit of our code. So I'll simply copy that down there. If this signer exists, we retrieve that from our database. Then in this case, we're going to change the state of our blockchain. And so we're going to check if it is started, if the task is started, okay? And to achieve that, we're going to do task manager dot, let's see, start task. And this one is going to accept a task ID, which we pass like that. Then if everything goes well, we should return is started. But just before that, remember we changed the state of a task. So we need to reflect that, or rather update that to blockchain. So to do that, I'm trying to see where we did it somewhere up here, so that we don't waste time rewriting everything. So I'll just copy that and write down somewhere here before we return the state. I just do my task.set signer, and I update it to the task manager object. So that will have updated the task, the state of that particular task of a blockchain. So if in any case, whoever signed this particular transaction, or rather called this function, did not have any persistent data on the blockchain, we just need to return false, because in that case, nothing is happening. They don't have any task already added. Then to complete task, the logic is simply the same. We're just going to change some little part right here. So in this case, we're going to complete task. You still need to specify the task ID, and we need to do our normal checking. And after that, we change the function, from start task to complete task, still specifying the task ID. Then we ensure that we update that particular change on blockchain by updating that record on our persistent collection, then returning the state whether it was completed or not. So just copy that down there. Else, we return false. Awesome. The other thing we need to do could be what? To remove task, right? So we need to remove task. By removing task, we need to specify the task ID here. And if we also need to get the wallet that called this particular function, we do a normal checkup, then up to there, we are good to go. So at this point, we basically need to delete, or rather remove, that particular task. And if you can recall very well from our function, removing a task should return to us either a task or a null. Okay. So in this case, we're going to see the task variable I've just written is going to store whatever task was deleted. So in this case, we're going to do task manager dot remove task. We specify the task ID, and that should do it. Okay, yeah, that should do it. So after doing that, we basically need to return this particular task that was deleted. Else it should return null. Okay, so right here, these should be null. In other words, there's nothing that was deleted when you invoke that particular function. And since this is also sort of changing the state of our object, we need to reflect that back to blockchain or in our persistent collection within the blockchain, so that we don't remove it just within the computer's primary memory, but it is still reflected within the persistent storage. So to achieve that, we basically are going to run this before returning that task. So you're going to do my tasks.set signer and then the task manager. I hope that is quite clear up to there. So this is basically our contract, our smart contract. This is basically the smart contract we're going to work with. Now, up to that point, I hope everything is clear. So I'm basically going to start writing the tests. Now, initially, I actually had written the test, so I'll just be taking us through them so that we don't waste any time. I'm trying to really be within the time so that we don't, whatever happened yesterday, we don't have a repeat of that. So, okay. Okay. So I'll just be copying the test code from where I had written, then as we explain. Okay, database.ts. Here is that. There we go. Right there. Yeah, I hope, okay, thank you. So I'll head back to our test file. So we're going to write all our tests from main.spec.ts. That should be TS, right? Yeah. So I'll basically delete everything right there. Then we begin from scratch. I like when we do it from scratch so that we know what's going on under the hood. So at this point, we first of all are going to do some initialization, like sort of what we need. So first of all, we need our contract. The contract class we've been working on right here, because this is what this is the entry file and it is what we're going to test. So we'll need it, and to do that, since we've exported it, we can simply initialize that as new contract class. That will bring it in as that has happened. Then we're going to also work with a signer, a wallet. So we basically are going to mimic a wallet address in this case. So we're going to call these, let's call this, let me use a name. Christopher, I hope you don't mind if I use your name. Let's use Christopher.testnet. Okay, then from there, we also need to bring in our database because we're going to store things, perform some tests also within our database. So we basically need to bring that in. we're going to import that as we proceed. Sorry, we should be able to import that as we proceed. Now, up to there, let's initialize, or rather declare, the start of our test. So we're going to describe these as tasks, right? And inside that, we're going to have a callback. And inside this particular callback, we can do our first test. Now, if you've interacted with the aspect unit tests, then this should be familiar to you. Describe function, sorry, is basically describing the whole set of tests. Then where the singular unit tests are going to take place is within the it function. So the it function is basically taking a description string of whatever you're testing and then a callback. So this is basically the convention of these functions. So let's say within the tasks, a group of tests, you have a singular test, sorry, or unit test called testing. Let's say should add what? Should add a new task, right? So that is basically describing what that particular unit test is trying to achieve. Then within the callback, this is where you're going to specify the whole body of your test within it. Okay. So like I said, I'm simply going to copy this from where I initially did it so that we don't really take more time on this. Awesome. So right here, we have, first of all, we are declaring a task manager variable, which is going to store my tasks. In this case, we need to have these imported. Why is this not happening? We need to have my tasks. Yeah, get some. And in this case, we're using the signer key. In this case, the signer key is the wallet address that was used to sign this particular transaction. Awesome. So these should give us a task manager object, or rather retrieve from this particular collection, a task manager object. And from that, this is the task manager object I'm talking about. From this particular task manager object, we're going to get an array of tasks for this particular person, for this user. Then that particular array of tasks is going to be stored inside my task variable. Okay. And I'll just talk about the logging in a bit. So in this case, we need, there's this task.title. Let me just have that as well brought in so that we don't get confused. Now you can specify a code that is going to run before or after each or before each singular unit test. And to do that, to achieve that, we simply write this function. So this is a before each function. So this function is basically going to run after every it function. Okay. So before this it function is run, this function is going to run, and we're going to have other it functions down here. So before this, the following it function is run, this function is simply going to be run. So that is basically what's going on right there. So we need to bring in the VM context, as I explain what that is. So VM context is basically an object within the NEAR SDK AS that is sort of mimicking a context in blockchain. Okay, because these tests are going to run in our machine, but then this object is going to help us mimic the environment of the context that that particular transaction was signed in. So in this case, if we were doing this from our terminal, you'd see me adding account ID, something like this, account ID. Then I specify my account right here. Okay. So in order to mimic this, we're going to use VM context to achieve that particular functionality. So we are setting the signer account ID, or rather the wallet address that is going to sign the transactions within this context. And we are providing the Christopher.testnet wallet address to that. Then remember the contract, our contract that we brought in. We are using it right here to create a new task, or rather add a new task. And this task is basically write bucket code, as simple as that, okay? So after adding this particular task, this is going to return to us some sort of, let's do this right here. Rather we do this contract dot, okay. Doesn't seem to be showing the accounts. So let me just check this from my end. We exported a class and we brought it. Oh, sorry. I think there's a confusion with what we imported. So what we imported was a contract object from near API.js. Okay. While what we wanted to import is in our index.ts file. I think that's why it was not cooperating. So now we can have a list of the methods we have within that class. And in this case, we are doing new task. Awesome. So by that, we'll have created that particular variable, the task variable, basically. So let me just have this up here so that it's going to be task info. So I basically declared the variable task up here so that we are able to do the assignment within this method. I hope that never confused us. Now, after that, we can log the task we've created, or the task, the information that has been returned by running that line of code. So at this point, we're basically logging it so that we are able to have a look at it. And right here, we expect the task that has been created, in this case, task.title, to strictly equal what is within our persistent collection. Okay. So to get what is in our persistent collection, we basically do my task. Remember down here, right? This is returning an array of tasks. And given that particular array, if we provide the task.id, this is basically the index where the task was stored within that array, then we get the title. It should be equal to whatever was returned to us up here. So let's just give this a try and run it in our terminal and see what that brings. So I'm simply going to do a yarn test. And as that tests, yesterday I showed us some script on package.json file. Now I told you we'll be using, I told you we'll be using whatever I've just highlighted, line 9 test script for our test. So in this case, we are utilizing ASP or ASPECT to perform our tests. So there's an error that is raising. There's duplicate identifier show task. Okay. Let's see what that implies. So we have show tasks, show task. Okay. I think those are duplicate. So this is what is bringing in the error. So I guess we can just get rid of that. I hope there's no other function here. Here duplicating within our code. So let's give this a try again. Let's see if our tests passes. It's still failing. It's saying that cannot find that name. Oh, so there's some things that I guess we never. There's some things I think we never imported, like task manager. So I'll just write this again right here, import it. Then what else? I hope that's it. Type void is not assignable to type void. Return created task. Okay. There's a lot of error within our code. So where's that? So right here, this should be task info, right? Yeah, that should be task info. Okay, so let's give this a shot again. Let's see what happens. Okay, Timothy file, what is no logo? So, okay, Timothy, that is basically, it's basically trying to, let me say, eliminate some information that you can see within your terminal while running the test. So, because you may find that there's a lot of information that's going to be shown while you run it without that particular flag. So by specifying that, we can just give it a try. Let's say we wanted, so instead of ASP no logo, we can just do from our terminal ASP. Okay. So you realize no logo, by running it with the no logo flag, it doesn't display this bit, what I've just highlighted, the ASP logo. I hope that is clear. Cannot see the window where you are running the test. Oh, sorry guys. Yeah, I'm really sorry for that. Let me just share. Just share the whole desktop. I hope you can now see. I'm really sorry for that. Thank you. Thanks for the reminder. I guess I'll have to start this again. So I'm basically going to run the test, and to run the test, we're going to do a yarn test. Okay. So that is basically going to test our file. Let's wait and see what happens. But I hope you guys saw the changes I was making in the editor. I really hope you're able to see all that. So let's just have these, let's have these run. The test is definitely not going to pass, yes. So you realize that this is the first time you are creating a task, right? And yet it is returning an ID of 1. In any case, we expected it to return an ID of 0 because the task is created within index 0. And that is why our test has failed actually. So in order to correct that within our code, we'll get back right here. And I'll simply open the task info class right here. So while we push, the push function is returning, is sort of returning like the length of the array, okay? As opposed to what we did yesterday. So in this case, we're going to subtract 1 from whatever index ID that has been passed down to this object. Now, if we do that, after doing that change, and we head back to our terminal again, I'll just clear this and try running the test this time round. So this time round, we expect the test to pass. As we wait for that, let me just copy the next set of tests and paste it. Yeah, here's our next set of tests. So simply gonna paste that right there as I explained through. Okay. Now, this particular set of tests is going to test if the retrieval is happening as expected, the retrieval of the added task. So I'm very sure you're familiar with the first, with line 28 and 29. So I'll explain from line 30. We basically retrieving from our contract, we're invoking the show task method, passing in the ID of that particular method, in this case 0. And from it, we're expecting the first task, or rather a task object that was created earlier. Then after that, in line 31, we are getting a list of all the tasks. So in that case, we're invoking the show all task method in our contract object. Then we are performing our test, individual tests, with the last 3 lines, that is 33, 34, and 35. So line 33 is testing if the first object is not null. So we expect the first task object not to be null. That is basically what is going on. Then line 34, we expect the first task object dot title. So basically we're retrieving this title instance of that object. So we expect it to strictly equal from the list of our task, that is my tasks, list of our tasks. Then we are getting the first task in that list, and we are retrieving the title of the object returned. So we expect those two to strictly equal each other. Then line 35 is basically testing if the length of all tasks, this length, whatever you're retrieving in line 31, to strictly equal 1, because in this case, we've only added 1 task. So we expect the total number of tasks in that array to only be 1, okay? So that is what is going on right there. Heading back to our terminal, our test passed. This is the test we ran before I added the second set of tests. So it passed, then it logged. Now, this time around, it logged the task info with an ID of 0 because of the change we made. And then the test passed. So I'll just clear this out for now. Okay, Obi, do you mind coming up again? Maybe you can unmute and raise your concern. Because I can't really get clearly what you're saying in the chat.
The issue has been fixed already.
Okay, okay, thank you. Thank you. Great, so let's head back to, oh, we were to perform another test. That is what we added, just the set of tests we added. Let's also see if that passes. So in this case, we're getting an error. There are some things we never imported, like tasks. So I'll just go ahead and have this brought in. What else could be missing here? Task info. The task info is right there. Okay, so let's give this a shot again. See what happens. Now, as that, oh, there's still an error. I cannot find the name task in our assembly script index.ts. Index.ts right here. That was line at 6. So we never brought in this task in, so I'll just bring in import that and run this again. Let's see what that brings now. As that proceeds, I'll just bring in another set of tests. So in this case, we're going to test. Let's see this. Great. So this one is going to test whether if we change the state of a task. So it should the functions we're going to invoke should change the state of a task, basically from active, completed, all that. So our first expect function is going to call the start task method from, rather invoke the start task method from our contract object, passing in the index of the task we're going to change, that is index 0. So we expect this to be successful. In this case, we expect it to be truthy. In other words, to be true. Okay. Then after that, we are changing. Now, in that case, we've changed the state of that particular task, line 40, that is, from pending to active. Now, in line 41, we are changing the state from active to completed. Then in line 42, we're basically retrieving whatever we have in our persistent collection, the object itself, and we are retrieving the list of our tasks, in this case, my tasks. Then we are testing if from that list of our tasks, the first task, if its status is strictly equal to the task status dot completed. Okay, this is an enum we created yesterday, guys, so please don't be confused. So basically checking if its status is completed after running line 42 within this source code. So let's see. Now this one passed. So we had 2 tests pass, 0 fail, and there were only 2 in total. So whatever we were testing right there is, so basically these 2 tests. Okay. So we're now going to run the test again, but this time around with these 3 tests and see what's going to happen. Let's see what that is going to do. Awesome. So as that executes, awesome, we still have an error. Return is completed. Type void is not assignable to type void. That is index TS63. We must be having some a lot of mistakes in this. So right here, that is completed right here. Okay, so we are returning a Boolean type, not void. Wait. Then start task is also returning Boolean type, not void. So that is where we made the mistake. So guys, you can see the importance of testing your smart contract before deploying them on blockchain. Because if this was a real world app and you went ahead and deployed on your mainnet without doing the test, then you get all these errors. then it means you'll have to create another wallet address, because you can't, if you're going to redeploy, then ensure that the state, you're not interfering with the state of the blockchain while you deployed your contract for the first time. So in this case, if we had our database, this is the only database we passed, and your changes does not interfere with this or does not add any other persistent storage, then you're good to go. But if, let's say, we were going to add another persistent storage down here or make some changes in the structure of this, then it means you'll have to basically delete that particular wallet address and sort of recreate it again, or create another one where we're going to have all that deployment placed. So that's why we have the testnet to help us achieve all that, or address all the issues, So with that, I'm simply going to run the test again, and this time around see what we have. As that runs, I'm going to simply bring in another set of tests. This should be our last. This should be our last set of tests. Okay. So in this case, we are testing whether we can remove a task from our list of tasks. Okay. So you realize I'm only invoking one function in this case, but then I'm reading the state of blockchain sort of twice. That is the first round, and then this is the second round. So the first round is basically getting the state of our persistent storage before we delete or rather remove any task from that storage, right? Then the second attempt to read the persistent collection state is basically trying to retrieve the state after a task has been removed. So line 52 is basically removing that particular task. Then line 52 is removing the task by specifying the task ID, in that case 0. So all that time we've only been adding, we've only had one task within our list. Then line 56 is testing if my task before removal, in this case the list of tasks before removal, if that length is greater than my task after removal. So we're basically testing if the length of this list is greater than the length of this list. In any case, we expect the length of the list before removal to be greater than the length of the list after removal, because we are removing a task from the list, okay? Then line 59 is testing if the length of the list after removal is strictly equal to 0, because in this case, we expect, since we've been working with just one task within our collection, we expect it to only have one task. And if that task is removed, then the length of that list should be 0. Okay. So that is it. That is basically what we've done right there. Awesome. So our test also passed in this case. We had 3 tests, which all passed. There are 3 total and 3 passed, 0 failed. So let's this time round go ahead and run the 4 of them and see what's happening. Let's see what this, oh, there's an error. Contract.remove task is not assignable to type. Type what? I'm not able to see it. Task info. Okay. Okay. So let's see, let's address this. So remove task is returning, remove task is giving us a task. Okay. However, from our index.ts file. Okay, we are still returning a task. What are we expecting in our main, in our test file then? Where is that? Right here. So these should be task. That should be task. Yeah. That should be it. Let's see if this passes now. Let's hope that this works now. Maybe as you wait for that to complete, if you have any question or you have any concern, you may just raise your hand, or you can just put it in the chat so that we address it. Awesome. So this one just passed. We had 4 tests, and out of the 4, none failed. Therefore, them passed. Great. So guys, that is basically how we do the test. That is how we test the smart contracts. Now, this is doing it with assembly script, okay? You may want to do that or to learn how to do that in Rust, because it will really come in handy when you're dealing with the real world projects. So please, you can read on that just to equip yourself. But with assembly script, that is how we go about it. That is basically how we go about writing these files. Now, up to that point, if there's no question, I guess you can just go ahead and deploy this guy on blockchain so that you guys are able to run it to invoke the functions from your end. If you already have near CLI, that is. So we first of all are going to build this smart contract. So we're going to run yarn build script. That should be able to build our smart contract. Then we're going to use the wallet. We're going to deploy it in the wallet we used yesterday, or rather we created yesterday, sorry. Now, you realize that we deployed a test smart contract to it yesterday, the Hello World smart contract yesterday. We deployed it to it. But then we've changed the state of our smart contract. So in any case, we've invalidated the contract we created yesterday, or we deployed yesterday to that account. So we will have to delete that particular account first, then recreate it. Okay. We may have to delete, then recreate it. But since I think I did that in the main wallet address. So to make things easier for us today, I'm going to create a sub account within that wallet address. Maybe I can just open up my browser and show these right here. Wallet.testnet. So wallet.testnet, this is our SA cohort 2. Okay. SA cohort 2. Then down here, we are told that a contract was deployed to this particular wallet address, SA cohort 2.testnet. Okay. Now I'm going to create a sub account to this wallet address. And how do we do that? Let's see. So we're going to run near create account. Then I'm going to specify the account address I want to create. In this case, I'm going to call it to do dot SA cohort 2.testnet. Now this is how a sub account of a wallet address looks like. You first of all specify the name of that particular sub account. Then you follow it with the name, or rather the account ID of that particular wallet. In this case, SA cohort 2.testnet. So that should be its extension, sort of. Okay. Then we're going to specify the master account as well as SA cohort 2.testnet. So by running this, we should be able to have a to-do.sa cohort 2.testnet account created. Oh, awesome. That was successful. So if we head back to our browser and refresh this page, then we should be able to see that activity listed down here within the recent activity sidebar. So we had new account created. This is the account that was created. Then we sent 100 near to that account, and we added an access key to that particular account. So that is a set of activities that happen by us running that command from our terminal. Now, we already have our smart contract built. So I'm basically going to deploy this to that account, the sub account we just created. And how do you do that? You run near deploy. You specify the wallet ID where you're going to deploy this particular smart contract, in this case to do .sa cohort 2.testnet. And then you specify the WebAssembly file that you want to deploy to that particular ID. In this case, it is under build /release/ let's get the name. I don't want to get this wrong. So right here, build release greeter.webassembly file. Now, guys, you can change this name greeter.webassembly file from your JSON file. It's using this name. So while we created the project, this is the name that it was given by default, but then we can change this to do. And after changing that, we can simply come here. Now I'll create another tab. Then I'll simply run yarn build. Then we see what that will give us. It should be able to give us a to-do.webassembly file. So we're expecting to have 2 files within this release folder. Let's just wait and see what that gives us. Great. So if we head back to that particular folder, you realize we have to do .webassembly, right? Code already right there. So that is what I'm simply going to use here. So I'm going to provide, or rather to use whatever we've just created right now. And I'll hit enter and wait and see what happens. So it's deploying and it's done deploying. So we can call those functions. Now this thing is on blockchain, guys. If you have near CLI, whatever I'm going to do from here, you can comfortably do it from your end, and you should be able to get the results. Okay. So in this case, I'm going to invoke the new task function. Rather, I'm going to add a new task. Okay. So I'm simply going to near call the account where we deployed our smart contract, in this case, to do.sa cohort 2.testnet. Then the name of the function I'm going to invoke, in this case, new task. And the parameters that this function expects is wrapped as a JSON object. It is expecting a title. And I'm going to give this a value called, what should we give this? Deploy smart contract. Let's do that. Awesome. So that is the parameter bit of it. Then I'm going to specify the wallet that is going to sign this particular transaction. So in this case, the account ID. So I already logged in with some other accounts I showed you yesterday. So I'm simply going to sign this using this particular wallet ID. The wallet ID I've specified is paul.testnet. So if I hit on If I run that, we should be able to create a task and it should return it to us. Awesome. So this is basically what it created. That is the object that has been returned. So if we were to run the show task method, okay, show task, in this case, specifying the task ID. What is our task ID? The ID is 0, right? So that is basically what we're going to pass right here. The ID is 0. Then we'll keep everything else as specified. Then we just run that. We should be able to get or rather retrieve the task we just created, and it should display to us that particular task. Okay, my internet is slow. Awesome. So we just got that right here. Now there's I think we may need to tweak some the logic while representing our task info, because remember we subtracted 1. So in this case it is 0, and it is subtracting 1. It's giving us -1, which is not that is not what we expected it to be. But all these can always be tweaked later. So basically that is it. That is a smart contract. You can try running it from your end and see what is happening. You can just try and give it a try from your end and see what that is giving you. So guys, I think that is what we had today. That is what we had to cover today. We were, yeah, basically testing smart contracts. That is how we do the smart contract testing. And I really hope you guys are working on your project ideas. Yeah, I really hope you've already started thinking of a project, a demo project that you're going to work on immediately after the end, by the end of this training. So if there's no other question, I don't intend to really keep you here any longer, unless there's any burning issue any of you might have. You can simply raise your hand. I'll give you a chance to speak or to air your view. Obi, you want some ideas? Okay. You can just think around, look at your community, at your society. What do you think you can implement on blockchain? It should be as simple as possible, because this is just a demo project. So it shouldn't be something really heavy that is going to take a lot of your time to implement. It could be a game, actually. It could be a game. Your projects are going to be graded by the NEA Foundation. That is the team behind NEA. Those are the people going to review your projects. Okay, so it should be something original. It should be something that has not been done before. And it should at least be addressing some challenges within your society, your community, sort of. Because, but if they don't like it, what happens? They'll just give you the feedback. Okay. You'll be given the feedback. We'll help relaying the feedback to you guys, just in case anything goes wrong. So you don't have to worry about that. You don't have to worry about that. Okay. Awesome. I don't know if there's any other person with any question. Anybody with any question?